Hello and welcome back to our YouTube channel. Today we will talk about white dwarf stars. So strap in and enjoy discovering one of the unimaginable wonders of our universe. Out there in the vast cosmos, among the glittering stars and swirling nebulae, lies one of the universe's most fascinating remnants of stellar evolution, the white dwarf. These tiny, incredibly dense objects are the final stage in the life of a star like our Sun, a star that has exhausted its fuel, leaving behind only its glowing core. But how do white dwarfs form, and what makes them so unique? To understand white dwarfs, we need to take a step back and look at the life of a star. Stars are essentially giant nuclear furnaces. In their cores, hydrogen atoms fuse together to form helium, releasing an immense amount of energy in the process. This energy pushes outward, counteracting the star's gravity and keeping it stable. This balance between pressure and gravity allows stars to shine for billions of years. But what happens when a star runs out of hydrogen to fuse? That's where things get interesting. In a star like our Sun, once the hydrogen is depleted, the core starts collapsing under gravity. As it collapses, the outer layers of the star expand, and the star transforms into a red giant. Imagine our Sun swelling to engulf the orbits of Mercury, Venus, and even Earth. It's a dramatic phase, but it doesn't last forever. Eventually, the star sheds its outer layers, creating a beautiful structure called a planetary nebula. What's left at the center is the core, a hot, dense remnant that we call a white dwarf. This is the fate awaiting our Sun in about 5 billion years. White dwarfs are incredibly small compared to their original stars. While our Sun has a diameter of about 1.4 million kilometers, a white dwarf is roughly the size of Earth, about 12,000 kilometers in diameter. Despite their size, they can pack up to 1.4 times the mass of the Sun into that tiny space. To put that into perspective, a teaspoon of white dwarf material would weigh as much as an elephant. This extreme density is a result of the core's collapse, compressing matter to a state known as degenerate matter. So what keeps white dwarfs from collapsing further under their immense gravity? The answer lies in the strange world of quantum mechanics. Within the white dwarf, electrons are squeezed so tightly together that they obey a quantum rule called the Pauli exclusion principle. This rule states that two electrons can't occupy the same quantum state at the same time. The result is a pressure called electron degeneracy pressure, which counteracts gravity and keeps the white dwarf stable. But white dwarfs don't remain static. Over billions of years, they gradually cool and fade. When they first form, white dwarfs can reach temperatures exceeding 100,000 degrees Celsius. They radiate this heat into space, slowly dimming over time. In theory, they will eventually become black dwarfs, cold, dark remnants of stars. However, the universe is only 13.8 billion years old, which isn't nearly enough time for any white dwarf to cool to this stage. Some white dwarfs, however, don't go quietly. In binary star systems, where two stars orbit each other, a white dwarf can interact with its companion star. If the white dwarf's companion is close enough, it can pull gas from the companion's outer layers, creating a swirling accretion disk around itself. As the white dwarf collects more material, it can reach a critical mass, about 1.4 times the mass of the Sun, known as the Chandrasekhar limit. When this limit is reached, the white dwarf becomes unstable. Its core undergoes runaway fusion, resulting in a catastrophic explosion called a Type Ia supernova. These explosions are so powerful that they outshine entire galaxies for a brief period, and they play a crucial role in the universe by dispersing heavy elements like iron and nickel into space. Even isolated white dwarfs have surprises in store. Some have atmospheres made of pure hydrogen or helium, while others are crystallizing as they cool. That's right. Scientists have found evidence that as white dwarfs cool, their interiors begin to crystallize, forming solid carbon and oxygen structures. Essentially, they're turning into gigantic cosmic diamonds. One famous white dwarf is Sirius B, the companion to Sirius A, the brightest star in our night sky. Sirius B is located about 8.6 light-years away from Earth, making it one of the closest white dwarfs to us. Despite being faint and small, its mass is almost equal to that of the Sun, packed into a sphere only the size of Earth. White dwarfs also hold clues to the age of the universe. Astronomers study their cooling rates to estimate how long they've been around, providing a kind of cosmic clock. This research has helped confirm that our galaxy, and by extension the universe, is billions of years old. But white dwarfs aren't just scientific curiosities. They also tell a profound story about the life and death of stars. Our sun, which sustains life on Earth, will one day become a white dwarf itself, a faint remnant of its former glory. Yet even in this quiet state, it will continue to influence the surrounding space, its gravity holding the remaining planets in orbit for billions of years to come. White dwarfs remind us of the cycle of life and death that defines the cosmos. Stars live out their lives, burning brightly and creating the elements that make up everything we see, including us. When they die, they leave behind remnants like white dwarfs, which continue to shape the universe in ways we're only beginning to understand. So the next time you look up at the night sky, take a moment to think about the stars. Some of them are still shining brightly, others are nearing the end of their lives, and some may already be white dwarfs, quietly glowing as they cool over eons. From their formation to their physics, to their role in the grand tapestry of the universe, white dwarfs are a testament to the incredible processes that govern our cosmos. They may be small and faint, but their story is nothing short of extraordinary. And that's the story of white dwarfs, tiny, dense remnants of stars with a cosmic story that stretches across billions of years. From their formation to their incredible density and their quiet transformation over time, white dwarfs remind us of the beauty and mystery of the universe. If you enjoyed this journey through the stars, don't forget to give this video a thumbs up and subscribe to the channel for more space content just like this. Hit that notification bell so you never miss an upload. Have any questions or topics you'd like us to explore? Drop them in the comments below. We'd love to hear from you. Thanks for watching, and as always, keep looking up and stay curious. Until next time.